Hey, Alexandria, you're the only one. Okay. Yeah, usually, well, it's only 8:01. Okay. All right. We'll give others a chance to join as usual. Hiram's probably on his way because he's the other one who's usually here at 8 o'clock. So it's great. So how are you liking the class so far? Is everything going okay?
Oh yeah, really
Yeah.
good.
Yeah,
Yeah.
and you're close to completing all the quests I see. So
Yeah, I have a bump with 9, but I'll
yeah,
get
yeah,
there.
but you yeah, but this is only week what is this? Week 9?
Yeah, like I finished the code, but I'm having a pointer problem somewhere.
Yeah, yeah.
Figure
You
it
got a
out.
lot of time. You got a lot of time to fix it.
Yeah.
Yeah. And most likely you'll probably even get a chance to, if you're planning to do 2B next quarter, you'll probably even get a chance to work on the first 2B quest.
Well, I might have to do 2B next fall if you
Yeah, no
offer it.
worries. Anytime you want. Yeah. So you got more time. But I think the 2B, you'll find them to be more fun than the 2A quests.
Oh,
So
2A was pretty fun, but yeah,
yeah, okay,
2B
cool.
should be fun.
All right, thanks for that. But yeah, I know, but a lot of students have a little difficulty onboarding into 2A because they're used to a different way of learning. And because even when I switched previously, I used to be teaching the usual way, give out these assignments and then, look at your code and then circle all these, writing stuff, and then give them back to you with some comments. And then also for good measure, I would not only give the assignment back with red ink mark saying these are places where you got to fix them, and I would also give them the model solution, right? So for every assignment problem, they would get back both the feedback as well as the model solution. And many of these model solutions were painstakingly crafted by Michael, because I inherited a lot of stuff from Michael Losef when he left. It kind of overlapped. He retired the same year I joined for, a sheer coincidence. And yet he, stuck around online for a whole year, helping me out here and there. It's very kind of him, really. So yeah, all his model solutions, I made available, and I was frustrated at that time, but not justifiably, I think, right? That many of these model solutions and feedback were not even being read. I mean, Michael put a lot of time into crafting these model solutions with tweaks in the code, which would only be appreciated by someone who'd done it the wrong way, right? Because otherwise, lots of things you just see and you take for granted. It works, right? You switch on your iPad and it works. But what about we don't pause to appreciate the incredibly hard problems that people have solved to get that magic to us, right? So, and we just take it for granted. And it's okay to take it for granted if you don't devalue it so much, right? So people just, I think it lost its value. It lost its value. And so it lost its value to the point I felt that it's not worth giving them out, really, because if you give them out, people need to look at them in detail to find out why Michael didn't do it the other way, right? So and then I found that a lot of students, even when I asked them in class, I found that many students didn't have a chance to think about these things, right? Because of the fact, and I was the culprit, right? I was the culprit because I told them the right way to do it, right? If you tell them the right way to do it, they're never going to find the wrong way to do it, right? Because who in their right mind is going to do something wrong just for so I figured I'm not going to give people the right way to do it anymore. In fact, I'm going to give them lots of wrong ways to do it. So in fact, that's why in many of my classes, I preface many of my classes in my syllabus, even my lectures in previous quarters, with saying, I give you a lot of facts sometimes, right? Even it's not my intention to give you facts. It's my intention to make you find facts, but I still give you a lot of facts. But the point behind these facts is not to give you the facts, but to tell you that some of these are not right, right? But you got to figure out. So how do you know? How do you know if what I say is right or wrong? And you can't take my word for it. You can't take anyone's word for it. You can't take any book's word for it, right? So the only thing you have to rely on is something that is inside of you. that sense, right? And it is a non-empirical sense. You just have a feel for whether that is bullshit or not, right? So you got to rely on that and sharpen that, right? You know, young children have that feeling, and it kind of gets blunted over a period of time. But we just have to resharpen it and keep it sharp, right? It's the spear of truth, the razor, Occam's razor, right? You know, it's a razor, and we have to keep it sharp all the time, so that it'll save us a lot of work downstream in life. Right? Not talking about CS2A, anything, C++, right? So that ability to think critically, scientifically about things, right? And appeal to that razor of ours to say, you know, is that true or not? Right? Or what is the likelihood? Even if I'm not able to tell if it's true or not, I should be able to come up with a useful distribution, right? It shouldn't be uniform, right? 50% here, 50% here. That's not useful, right? Because uniform distribution is the lowest possible entropy. There is in terms of informational content of a probability distribution. If you major in information theory and so on, you can find out how much information is contained, right? So uniform distribution has the least possible information because you can't tell which one is going to happen. Right. On the other hand, if you have a distribution in which one thing is more likely than another, then it's not uniform, right? So it's peaked. Somewhere it's peaked. There's one or two modes, right? One or more modes in there. So then you have information in that distribution, right? It's useful for us to know where these modes are. So when you go away from this uniform distribution, what do you appeal to? You got to have that razor to bin things, you know, a positive example, negative example, so you can get these distributions set up in your mind so that you have something useful. And so we have, let's say, not a uniform distribution, right? So what is the basis for? And I think that's a base. So I want to load you up with lots and lots of facts and say some of these facts are true and some of these facts are untrue. Right, and you got to find out, and I think that is the way that I'd like to have been taught when I was a kid, is to just be given lots and lots of facts, and then people say, well, which ones are true, right? Find out, right? Find out which ones are true and which ones aren't, which one works, right? And so if you look at the progress of civilizations and thought, many civilizations, right? And I'm not just talking about the current Western civilizations, right? I think where is it going? That. Gee, I don't know where I was going then. But essentially, we just want to say, we want to say, initially, everybody, in every civilization, there's bound to be people who have a very narrow view of the universe, of the world, and say, this is the only way to reach the truth. This is the only way to try and find it. This is the only way to find happiness. There's no other way to find true happiness, right? Or this is the only God. This is the only, and so only, very exclusive, right? But then we realize, okay, well, it's okay. We can't say that people cannot believe that. It's everybody's right to believe that, right? But the realization that everybody has a right to believe whatever they want, right? Whatever they want, as long as we all agree to live together as a happy, harmonious society, that's all matters, right? So we just lay the groundwork for something called a dharma, right? So we just say, this is what we're going to have so that we all live harmoniously, but everybody can believe what they want as long as nobody infringes on another person's happiness wantonly. Right. And so, people often ask, why do we have, in India, for example, or other certain countries, right? So 33 million gods, 15 million gods. So it doesn't matter. You can believe anything you want as long as you abide by it. And then ask yourself the question, is that conducive to my happiness? Is it leading to my long-term happiness, right? And so that razor within us needs to be cultivated. I think that's really where I was going. And sorry for all this digression, right? Because, I was waiting for other people. I was trying to keep the airwaves occupied. And, I was talking about all that stuff, but I think it's all related, right? In C++ also. And don't take my word for anything I say. Everything I said in the last 10 minutes could be false, right? So how do you know if it's true or false? And so the only way you could tell is by appealing to your own reason, right? And not by asking other people, not by checking 100,000 journals and looking at what famous people said about that. Right. So you can say, why does it make sense? Does it make sense? Right. So when we say, does it make sense or not? That means we have found sense, right? Because we have something to compare it to. And that sense is what we need to cultivate and identify and not lose, right? And have a razor that's kept sharp forever so that we can always bend things into, makes sense, doesn't make sense. And so, facts. And so, going back to assignments, I said, no, I'm not going to give model solutions anymore, right? I think it felt to me like, I was totally wasting. Michael gave me this trove of treasures with so many things. And I was basically just throwing them out to anyone who comes knocking, who doesn't even need it. I just give it to them, right? What's the point? And I don't know if Michael intended that to happen, but so I figured I might as well, I start hiding them inside these hard to earn quests, and then I did a couple, and then I actually got addicted to it, and then I created a whole lot more quests like that. And in fact, and after a while, I ran out of stuff that Michael gave me, and I created my own too. So there's a whole bunch of quests that Michael created. Not my quests that Michael created, quests that borrow from Michael's ideas. When he created assignments for CS2A BC, right? Because there's always been talk in any department in any university to abandon old stuff and start being topical, and I felt that it's okay to abandon old stuff. It's been superseded and gotten better, right? But there's a lot of stuff. There's a lot of really beautiful things in old literature, in computer science, in Knut's books, right? In Michael's labs. And I think that, and when we had a discussion, we actually had a discussion in our department saying, should we basically just completely abandon all of Michael's labs because of the fact that his model solutions have been given out and lots of people have them free, is they're not really helping anyone, right? So we actually had a discussion about that. And then I decided that, no, I think we shouldn't completely throw it out. You can't throw the baby out with the bathwater. So there's a lot of good stuff in there. And there's more good stuff than, the disadvantages of it being extant. Everybody has access to it. So we should keep it. And so that's why they've been kind of reborn in a slightly different guise, although changed in many places and new stuff has been injected. Quests are really version 2 of Michael's labs, really, if you think about it. And I don't know, no, none of you, Agnes is the only person actually who's not in class today who's done Michael's labs, right? Because she did my CS2A before I started quests. And at that time I was still using Michael's labs. I didn't even switch over to Zybooks, right? So I was using Michael's labs. And yeah, so she probably remembers many of these assignments I have, and could relate to, well, I don't know, some of the later blue quests have already started diverging. But in 2C, I used quite a few of his lab work adapted into quests, and 2B also. Certainly cellular automata, right? Because many people don't even teach. I think in other colleges, cellular automata is not part of the CS2AB syllabus at all. It's not part of the syllabus. It's not being taught formally, but it's a very nice instructional vehicle, and he used it, and I liked it, so I'm also using it. So if you do CS2B, you're going to be learning about cellular automata, right? Which is very nice. You'll be doing that in lab quest number 3. And it kind of maps to, I think Michael used to have his 2B students do it in lab number 2 or something like that. So we do quest number 3. So it's all very nice. I absolutely love the fact that we have, every quarter we have some bunch of lively engaged students who actually take this seriously, right? And meaning that there's some track that intends to major in computer science, right? Because 2A is always a mishmash, right? Because it's open to everyone. Anyone can come. So we have people majoring in anthropology, history, who just want to take a peek at computer science and see what it's all about. They come. So 2A is a very hard course to teach because we need to cater to experts who are going to major in computer science, as well as people who are just coming to peek. We don't want to scare them away or give them a bad experience, so that when they come back later, right? Maybe, someone is a kick-ass actor, right? Or someone like that, right? And who wants to take a peek in CS2A. We don't want to scare them away. I think I've told you the story before. Maybe, he majors in acting. At some point, they say, I want to go back to computer science, right? And bring my acting knowledge to bear. Maybe they create the new version of, Unreal and VR or something like that, right? With their acting stuff built in, right? So some expertise they brought in there. So to attract that kind of thing, I think we have to be very careful in 2A. So yeah, so that's the other discussion we're having. You can always send an email to Beta, me, Ram, with suggestions, because these are discussions we're having in our department meetings, right? Saying, where was I going with that? Adjuncts or people who have been who have a lot of experience, because computer science at Foothill is a small department with lots and lots of adjunct professors, right? So adjuncts are people who actually work out there in the industry, who sometimes are able to spend time lecturing to a student per quarter, for students for a quarter. Or 1 or 2 quarters, we give them these contracts, so they come teach this on the side, okay? And they get paid for it. It's actually very nice because they also get to interact with students. But because we have so many different subjects and we don't have expertise within the department to be experts in all of these different areas, to stay up to date, right? Let's say for, something weird happens in quality testing, there's a whole new paradigm there and we don't have time to invest. So we have to be open to the fact that, someone who's had reasonable experience and teaching skills can teach that course. But we still have a challenge that sometimes we have understaffed 2A, 2B sections also, right? To 1A, 3A sections. And there's a question as to whether we should add which of these core courses, we call the programming track, right? The programming track leads directly into graduate study and, all those stuff. You go to a UC, they actually have these requirements. You have to have done 1 or 2 ABC before you go on to some, machine learning course there. Also, they have these prereqs, right? I don't know, Ram knows the details. So, so we have these discussions saying, all right, so we need to make sure that these core courses are only taught by these difficult courses. These difficult to teach courses are taught by full-time faculty, right? Who've been in the college long enough to know the challenges of teaching this bunch of students, right? Because again, community college is different from universities, because universities already, many students, when they go, they have made up their mind what their major is, right? They're going to be a CS person, or right? Community college is not like that. Many people are still in a mix, is trying to, so it's a different kind of students for 1A, A-level courses. And so we need professors who've been in here long enough. Even if you're an adjunct, we've taught our student population long enough to get a feel for our first year students, which is very different from our second year students, right? So, for, BC and those students are majoring, they know what they want to do, right? So you can teach them with a different mindset, right? You can be completely online, but you can be more confident. They'll just do their work, they'll show up and things like that. But first year students more challenging, right? You have to be teaching at a community college or like Foothill for several years before you get a feel for this bunch of students who are, many of them are fickle, not because of a fault of theirs, because they're from a different varieties of, different departments. So we got to be very experienced and know when students are slipping off, right? Got to do different things, sufficient different things, related things to keep them all drawn in. And when they do go, we got to make sure they go with a good taste, not bad taste. So those are things that you only pick up with experience teaching a certain group of students, because you need to know, right? The pattern hasn't changed all that much. We always have some group of students who show up early and work through the class and work through homework, ask interesting questions. They have interesting, rich profiles and so on. So, and there are also students who are checking out. They want to know what it's like. They want to know if there's something here they can take to their work, which may not be directly related, but it's, tangentially related. So we got to be able to cater to everyone and not, and make sure that nobody's left behind, right? And again, I do want you guys, who show up early, who are interested in the stuff, right? And probably, computer science, right? Computer science mind people to do 2B, okay? I'd like it if you guys do 2B, because I think you'll keep progressing on, right? Without anybody else, and you'll be able to help other people, right? Because once you have a bunch of people, it's like a snowball, right? So other people will follow and more people will join, and it'll be fun. Yeah, 2B, I think will be a good option for the ones who are really interested in computer science, right? And then I'm pretty sure that most of the UCs, right, especially Berkeley and Santa Barbara, I know, right, they're C++ schools. So you got to know. So if you did 1A, 2A, 3, no, was it? Yeah, 1A, 2A, 3A. Yeah, I think it's a different set of schools in the UC system, right? I think, I don't know. Even nationally, right? So I think they're segregated into Python for CS, Java for CS, and C++ and for I think so, right? Yeah, I think there's these 3 different kinds of schools. So you got to, so the choice you make about the schools you want to, ideally that shouldn't be the reason, right? People choose a language based on the school they want to go to, right? Now they should choose choose a school that offers the language they're interested in. That should be the right attitude. And so, yeah, so this is a great place. You can sample the Java track, beta. So many people teaching here, right? So even full-timers. And yeah, so you can absolutely do that. All right, I think we have a quorum in class now. We can start doing stuff. By the way, Thursday, I think there's no class because it's obviously it's Thanksgiving. But all you have to do is just email me, because this time, even if it's Thanksgiving Day, this time of day, I'm okay. I'm free, right? I'm okay. So if you want a class, you want to do, go over some stuff, even tangentially related to computer science, or you're doing a program, JavaScript with the C++ interface, and something curious, something interesting that both of us can, do online research and solve together. That's fine. This 2-hour block, I still have it, penciled out in my calendar. So just let me know. One day before is fine too, and I'm happy to get together at this time. Okay. Otherwise, no problem at all, right? I'm okay. And then that means you have a very long weekend, so we won't meet until next Tuesday again. You got 7 days, right? And that doesn't mean that you should basically take off for 7 days, because after those 7 days, you only pretty much got 1 week to wrap up all of your quests, right? Because finals week, you should just be looking at the final stuff, all of it. So starting from that, you should be reviewing stuff, right? So reviewing data representation, coding, all of these things, looking at your quest code and looking at, the modules and the sample code provided in the modules. All of those things will help you for the final exam. Yeah. So yeah, so you only have 1 more week to wrap up quest number 9. So that's, you still have plenty of time. If you already started working on quest number 9, I think you're pretty good, right? You'll have a lot of time to finish quest 9, and then you can go back and polish up all of your quests too, if you want, right? Or you can say, I'm already an A+ in CS2A or something like that. I'm not going to do much more of polishing up the earlier quests, because I'm maxed out on I think 210 points. I don't know, whatever the max is in the syllabus, right? I've got that many with quests, so I'm just going to stop there. I'm not going to polish the earlier quests. I'll go on to CS2B, because you get the first password, the password for the first 2B quest at the end of CS2A's 9th quest. You get that, and you'll find that the first 2B quest is very similar to the last quest of CS2A. So you're easing into CS2B, and it'll be fun to do so over the holidays or over the winter break. I think that'll be really cool. Yeah. So yeah, so you can. I think you'll have a great deal of fun. So you do that over the weekend. You should keep thinking about it. It'll be fun, right? I'm really hoping that some of you will just keep going on and on, right, all the way until CS2C, right? Maybe give it 4 quarters from now. Maybe by next fall, right? By the end of next fall, maybe you've completed CS2C. Right? Or maybe you've completed CS2C and you're interested in a project, right? And you're interested in probably doing something really cool, maybe in the cloud, involves C++, Lambdas and Python and things like that. You want to put things together. You want to have an interesting discussion, right? And then maybe a bunch of classmates here, or maybe I'll get together. We'll set up a subreddit or something, have an interesting project we all put together, right? And that will also be fun. We could do all that after you complete CS2C. Right? And it'll be fun along the way, I'm pretty sure, right? You just have to get used to it. Face it, you've spent almost a whole quarter of your time getting used to the questioning system, right? There's time invested in it already, so you might as well throw more good money after that and say, okay, well, I've done all that now, hard work now of getting used to the questioning system. I might as well blow through and get to quest number 9 off red level quest number 9, right? Very it'll be very challenging as well as very interesting, I hope. All right, if you have any questions, I'm happy to answer. Otherwise, I think what we'll do today, I think today's plan is to, I think what we do, we're okay with link structures, pointers, and so on. Yeah, we'll do a stack. Yeah, we'll do a stack. We'll do a stack that's based on linked lists, okay? Based on link structures, not linked lists, okay? Link structures, and we'll do. And I'll show you how interesting and easy it is, and some things that are, yeah, okay. All right, well, I'll talk about some interesting stack-based problems also, right? And the advantages and disadvantages of doing it with an array versus doing it with a list and things like that. We can talk about that, brainstorm them together, right? And we can do that. That's right. And next week, Oh, gee, yeah, next week. Oh, that's it, right? Today. And Thursday, we can do more of this if you want on Thursday, or do other stuff too. That's fine. Next week is the only week we have left for classes. Correct me if I'm wrong, right? Because I'm not allowed to lecture. No, I'm not. No, no. Let me take that back. Okay. Foothill does allow you to lecture, right? I think we're not allowed to introduce new material to students, right? Because it's I think it's unrealistic to load students with material and give them only 1 week to answer them in a final. So I think that's a rationale behind it. So finals week should just be study and review. So we're not allowed to. Well, we're recommended, strongly recommended, not to introduce new material in week 12. So anything I introduce in week 12 and you see that being asked in the final exam, you should basically just send me an email and I'll reiterate, reinstate the points for those lost points. Okay, so that's just pass that message on to your. I'm not going to introduce any new material, right? So week 12 should be review. I'm happy to answer all questions you've already had. So that's why I'm saying next week is the last week of classes, and then we'll do linked lists. And with the linked list, I think what we'll do, I had an idea, right? Because I was thinking, well, you know what, if I'm going to implement linked lists on in week 11, that pretty much solves week, the bulk of quest 9. So should I do that or not? So I think what we'll do is implement linked lists in class the hard way, right? Which means without the use of the head pointer. Right? We'll try and use it. We'll try and do. I think so, right? We'll find that many of the operations are very similar, but some operations are, going to be horrendously hard just because we don't have the head, right? And I think so, right? I remember. I don't know, but I'm pretty sure because I remember when I was a student anyway, I encountered these problems. And problems don't go away, right? So there's a good reason we came up with these solutions for them, like the head pointer and so on. So still people are using them, so obviously the problem is still there. So yeah, we'll implement it the other way and find out what the problem is. Help refresh my memory also. So we can do that on next week. So it will actually be an instructive week, right? Because if you look at question number 9 in the spec, I say that we're going to use a head pointer. Why? I can't answer the question here, but you got to implement it without the head pointer to know why. All right. So I think that's what I said in the quest, and then I left you to implement that in your own time. But we can do that. We can do that in class. Okay, we'll do that in class. We got 2 lectures, week 11, 2 lectures, and one of you can take the screen and we can code linked lists without using head pointer and see what issues we may potentially run into. Does it sound like a good plan for wrapping up CS2A? Yeah. So that I think that, and I think that is also consistent with what the syllabus, or even not even forget the syllabus, right? That is what the state requires us to teach you, right? And please do. I know that even though there's only like a bunch of you here, it's not like there's all these other students who are also enrolled in class. And it's not like you're not in touch with them, right? Because I know I was a student too, right? Because I'm not able to make it to some classes. Maybe I have some pressing engagement on so I never make it to a particular class. But I know I talk to other students, right? So you have to pass this message on to all these other students. Everything we're talking that's important, please do, right? Because these other forums, you have like an infinitely greater number of forums in which you can engage now, right? So you should pass this message on. So those of you. I can't see. I forgot what I was going to say. Damn. Yeah. I think if if you want to do you want to get up to pointers, okay? And if you just want to pass 2B, do not consider enrolling in CS. If you want to pass 2A, do not consider enrolling in 2B unless you get to quest number 9, okay? So I think there are a lot of students who just want to get to ABC on their transcript, right? Because I think that's what we found in the last few quarters. They just want 2 ABC on their transcript. So, which is okay. You can get 2 ABC on your transcript. If you get up to quest 9 in A, and then quest 9 in B, and then maybe quest 6. And you don't have to go all the way up. You have to pass quests, but you cannot do B without with just a pass in A. That's what I mean. Okay. Yeah. Okay. And you cannot do C with just a pass in B. And I don't know, how do we formalize that? Maybe you can send suggestions to Ram or Beta or some of our other admin folk. We don't know, because according to Foothill, if you pass a course, you are advised not to enroll in the successor course, but you are entitled to enroll in the successor course, right? So there are a lot of students who just pass 2A and get into 2B because they passed 2A. And you have to get this message to them, okay? They should not enroll, not just mine, okay? Even other people's sections. Because essentially what happens is that if they pass 2A and get into 2B, they're not even, they got 50% of the way in 2A, they're not going to get 50% of the way in 2B. They'll only get 25% of the way in 2B. So they won't even pass 2B, right? And if they do pass 2B after having just, passed 2A and, not done anything after the pass, that is something that is a problem for the department. Okay, so we need to escalate that, and we need to look at that more closely. Fortunately, we're doing a program review this year. Okay, so each department at Foothill only gets one chance every 5 years. Okay, and all of these things should change, right? Because everywhere else, everybody's agile, right? Everybody's changing things every day, right? Right now, as you and I are talking, maybe Microsoft Windows rolled out a change. Who knows, right? So maybe Google search using a completely different engine. So all of these things are happening in real time. So I think institutions should also adapt so that we can make these changes more nimbly and quickly, right? So education also changes in step with technology and everything else out there. So this year, fortunately, we have a chance to do what is called program review. And this is a time when we can look at everything that is going wrong and look at, why enrollments are suffering and, why certain groups of our students, they're always lagging behind, right? Why is it that only, some bunch of students always turn up to the first, it's okay with A, okay, I can understand, right? Even for B and C, sometimes we have classes, there's only some bunch of students who always turn up and the others basically trail off and drop off. Why? Right? So stuff like that, we try and collect data and look at trends and see, how can we address this? What are things that we should fund more to draw them in? That's the result of the result of those things are things like STEM Center, right? A long time ago, we didn't have a STEM Center, right? And we're just shooting in the dark, essentially. Not shooting in the dark, but shooting in the dark. But the result of a lot of data collection to find that there are certain groups of students who are basically missing out, right? Who are not able to learn these things just because they're missing skills unrelated to 2A, right? So we said, okay, let's invest in a STEM Center. Not just in PSME, right? All over the college, everywhere, every university, everywhere. So that's what they're looking at. When people have, retreats, off time, that's basically what we're doing, right? We're in program review, and hopefully we'll get more chances to do these things. But these are times when you can expect overhauls in our department, meaning things change fundamentally. The structures of what we offer may change, right? So we'll say at Foothill, we did a study this in 2021. We did a study and we found from the data we gathered and other data we found these things are not working, or and we have to make sure that this track is I don't know. So, and also we one of the things I am collecting more data on is some basically from feedback from you guys. Okay, one of you told me early this quarter, I think in 2B, that the reason for the poor performance is because a lot of 2A students got graded on got a grace pass, even though we're graded on effort. I totally did not. I suspect that. And as soon as that person said that, I collected some data and which seemed to support that. And then I discussed that with other faculty members, and they all seemed to agree. And then the dean said he's had similar information come to him from other faculty members too. So which means that it's harder for faculty, right? It's harder for faculty to do the reset because you can't completely do the reset until becoming, unless, as some people will think you're a bad faculty, right? So they don't grade you so well. It's very hard to get an A at Foothill and things like that. Yeah, okay. So the reset has to happen at some point. Maybe it's this year. I don't know. Who knows? All right. So anyways, that's what we're going to do. I think. I don't know how we got started talking about that. It's 8:35. All right. Again, and none of you got a chance to talk, and I was just blabbering on and on for the first 30 minutes as usual. But I think it's time we can start. Yeah. If one of you can pick up the screen and well, let's start with an empty slate, right? Just blank.
I can take the screen.
Yeah, Wesley, thank you very much. And yeah, I think Jared went recently. Yes, Jared, you took the screen recently, right? 2 lectures ago. Hiram and Alexandra too. So yeah. Maddie, you're feeling better now? You haven't taken the screen recently?
No, not recently. Did you
Maybe
want me to?
next week you can consider when we start coding lists.
Yeah, sure, absolutely.
You have a computer all set up for all that, right?
Mhm.
Great. Hey, Lei, just take the screen anytime you're ready.
Yeah, I'm just logging.
Are you on campus? Are you on campus right now?
No, I'm not. I'm actually not even. I've never been on Foothill. I'm a student at UCSD. Yeah.
Sorry, Alexandria gave you a thumbs up. Oh, you're not even at Foothill, you're saying. I was just trying to make out what those things are behind you.
That's just some sort of curtains for the window.
Oh, I see. You're not at home, obviously. All right.
Yeah, I'm at home. Actually, I'll just use online GDP because.
Yeah, I think that's what you used last time too, right?
Last time we were using Replit, but Replit requires you to log in.
Yeah. On GDP, let me see what we can do. Yeah, let's create a stack class, and then we'll build it up organically. All right, let's build a stack. Yeah, delete everything and Control A, delete, and then Control A. Is this a Windows machine? Yeah, it's a Windows machine. Control A and delete. Yeah. All right. Now put a comment there saying today's class, whatever it is. What is today's date? 22nd? Is it 22nd today? Yeah. Yeah. Today's class code at 23rd today, is it?
Yes.
Okay. All right. Let's say in a comment you can say we'll try and implement a stack using linked nodes. Okay. Oh, you've done already. Okay. All right. Now let's go ahead a couple of lines down. Do your hash include. Oh, I see. You know what? Rename the file as stack. Can you rename the file? Do you have an Explorer? Do you have a package Explorer? Oh, you don't. Just rename it.
Or I can make a new file.
I see. That's a new file. Kill that. We can kill that. Oh, you have an X. Oh, now it created untitled. Yeah, all right. Go to untitled and call it stack.h. Leave the main. Yeah, rename that as capital S stack.h. Because let's follow the Java convention, which I like, which is to rename all classes with first letter caps. I think it's really nice. Obviously, you don't have to do it. A lot of system code in C++, if you look at Linux code and all, their classes don't start all with uppercase. They're regular guys. I mean regular names, but we'll just do it here. Small programs, right? So it's okay. Yeah, just do class stack, and we'll have to introduce hash includes at the top at some point, and then put a comment right at the top saying this is an implementation of a stack class using linked nodes on the heap, right? Linked nodes on the heap. I think by implementing that, we will get to play with lots of things that we have done before, right? Allocation, deallocation, constructors, destructors, and so on. Okay, put a blank line after the comment, and then we'll start the class. Okay, yeah. All right. Now open brace and go to the next line. So that's our class stack, right? All right. Now what we want to do in our stack is before we even declare what the stack is going to contain, let's just declare the interface of the stack, saying this is what the stack needs to provide to others. Okay, so let's just say public, right? Public, right? And then a colon. Oh, it didn't unintended. All right, push the public all the way to the margin. So make it, yeah, right. So it's one of the styles that is very common. Also, on the next line, you can indent in. And so these are the public methods that the stack has to provide. Let's say we provide a constructor. Okay, let's provide a constructor. Yeah, let's provide a constructor stack. Yeah, okay. Right. Also, let's provide a destructor, a semicolon right there. Yeah, a destructor tilde stack. Right, the tilde stack is what destroys the stack. Right, every time a stack is constructed, it also needs to be destroyed. Yeah? So it's a tilde stack. Okay, those two things we're going to have to write. Right, hopefully you're going to have to write. Okay, so we'll just flush in the comments, and then you're going to have to write. Maybe you're going to get together on Thursday like this, right? And you're going to write it. right? By yourself. Okay, now this is going to be a stack of, let's just say, this is going to be a stack of strings, okay? Let's say this is going to be a stack of strings. So up in the comment right at the top, you say stack class, and then within parentheses, you can say of strings, stack class of strings. Stack, okay, all right, that's fine. Okay, and maybe we can even call it str stack, okay? Str or string stack or something, just to make sure it's all very clear. Str, okay, str. Do you want to call it like that? Okay, str stack is good. All right, good. Excellent, thank you. All right, everybody okay with this? All right, anybody who is not okay, just need to speak up, okay? Right, okay, everybody's here anyway. All right, so what else do we need for a stack? We need a way in which a stack needs to get, once you have a stack, you need a method that will say, here is something that you're supposed to contain, take it and put it on the stack. So what we need is a function called push, right? So something that says, push this on the stack, okay? So we want to say push, and what should push return, right? Let's say push would return a, let's say void for now, right? It's not going to return anything. However, because it's a small function, which is open to the possibility that when we're implementing push, we may find that it is sensible to return a value, which is also conventional and programmers look for. At that time, we should be able to go back and change the void into a bool or something like that, okay? Usually it's a bool, right? Why is push a bool operation? Because sometimes when you say push this on the stack, you say, well, I wasn't able to push it on the stack. In this case, very unlikely you're going to be able to do that, because you're going to ask the heap for memory, and the operating system will give you memory even if it has to kill the machine to do it. That's what happens in the newer architectures, right? Well, not newer architecture, I shouldn't say that. In many machines, right? The operating system will just keep on giving you as much memory as you ask it, even if it means slowing the rest of the processes on the machine down to a crawl, which means that most of the processes will die. That's what happens, right? So if you start up a machine in the cloud, and then you have one small process that keeps getting memory, right? And not doing anything with the memory, just getting memory more and more, right? Now, there's a limit to how much memory you can get locally on the stack, right? Every machine, every program that's started up, the operating system starts up with saying, okay, well, you got like 200 megabytes of stack. Okay, every program that starts up gets 100. In fact, on most machines, if you get a shell on online GDB or Replete, you can find out, right? It's probably a setting in the shell that says, every program that starts up, give it that much stack size, or it's built into the, when the program starts up, it allocates that much stack. So that means your stack is limited in size. However it's organized, right? So whether it's organized in chunks of memory or the operating system stacks, the operating system stack is different, right? The OS stack, let's not go into that, okay? So every program has about 200 megabytes of memory. So you can't get more than that in stacks. Automatic variables, that's all you can get. However, when it comes to heap, even a small program, right? Even a 5-line main program can keep on allocating memory until, the operating system is exhausted. Now, the thing is, even if I have only in a cloud, right? If I have, unless, if you can have policies set up so that everything is gated and, policed very hard, but, most people don't do that, right? So if you have a small main program that just keeps on getting resources and not using it, right? Just locking it up in a vault, right? Not even using it, just taking memory, releasing it, not releasing it, just letting it go, right? Float. And do that. What happens is that the Unix anyway, right? Unpoliced Unix will just keep on giving you memory. And even if it has, let's say, 16 terabytes of memory, real memory, it'll keep on giving you up to 16 terabytes. And at that point, it'll say, well, you still want more memory. What I'll do now is start swapping out stuff, which means it'll take memory that's already allocated, write it to disk, right? And create an entry somewhere saying, well, that much memory has been freed up and can be reallocated. However, if the original owner comes back, then I'll, take the new guy and put it back to disk and take this and load it into memory and give the, so all that mess has to happen. You can see how messy it gets. Fortunately, all that mess is hidden away from us. The operating system handles that. That's called the swapping, the page swapping, right? So, and you can see that when you have a C program, rarely happens in C, right? Always happens in Java, rarely happens in C when you have a long program, right? Running for several years, right? Allocates memory and deallocates and so on, fragments and so on. Even that suddenly locks up for a few seconds, bam, like that, right? And then you look at the system activity and log and so on, you'll see that the pager kick in right then. right? And how do these things happen, right? So you get to the bottom of this, you find out that the operating system decided, well, I've basically run out of juice now. I've got to start paging, and so that's a problem with so with stack. You can grow all the way. So with this small program that you write, you can allocate as much memory as online GDB will let you allocate within that virtual machine it's created for you in the cloud. Right. So the way that these guys online, all these other people work is basically they just give you a virtual machine for free. That's essentially what happens is that these days that's the easiest way of taking care of this memory unbridled memory allocation problem, right? Is to basically say, you want to run a program, I just give you a machine, right? I just give you a complete machine, take it, okay? You want to screw around, you want to go into the root and screw up the entire machine, blow up the entire machine, fine, go ahead and do it, right? Because it's not a real machine. I just given you a virtual machine. Right, and this virtual machine, I have a 15 terabyte machine with lots and lots of RAM, but I'm not going to give you the 15 terabyte machine. What I'll do is I'll take a small chunk of it and make a virtual machine out of it. Right, that's called a Docker image. It's basically, it doesn't have to be Docker, right? It's just a virtual machine. The concept been around for a long time, right? So I just give you a small machine that's manufactured out of that big chunk, right? And you can go and do whatever you want, and you can make so many of those now, countless amounts of those, that these are basically cheap. That's why when you go here. Even on here, I'm pretty sure, right? You just basically get a machine. That's what you do, right? When you come questing, or even when you come to browse on the questing site, I basically just give you a virtual machine, right? So essentially, you can go and do whatever the hell you want with it, right? So you can go into the nooks and crannies of the machine. There's nothing to be found other than basically the quest that you have, and that's why it's easier for me too, right? So I don't have to worry too much. And that's what everybody does, right? Everybody, Amazon, Google, everybody, right? So they're not going to worry about, coming into their system and hacking, because, they just give you a virtual machine and say, all right, there's no way from this virtual machine back into our system because it's really, really hard. But inside of here, you can do whatever you want, right? And I think that's what happens here too. So we can actually find out how much memory we have. In fact, one of you should write this program, online GDB. It'll be fun, right? Online GDB, they're not going to care, I can assure you, right? It's okay. Online GDB, write a main program with a main loop, which basically just going to allocate new 100,000 byte char array, right? Keep doing that on loop and keep a counter, right? Saying how much memory I've actually got on this online GDB computer. Right, just run it, and it's just going to keep, allocated 100,000 bytes, allocated 200,000 bytes. Right, at some point it's going to start slowing to a crawl, okay, and at some point online GDB is going to basically say, well, that image is run out of resources, not making any progress. I'm going to kill it. It'll die, right, or timeout or something like that. So you'll know the maximum amount of memory you can get from the heap on this compiler. You can run the same program and replete. And you can find out how big their machine is, right? You can find out all these different images and say how much resources you're getting from all these different machines, right? And you can run all these experiments, right? You can run a job here, a job there, see how long they take to complete, right? A job on here, different times a day. The funny thing is people are doing this, I'm just talking about, I'm pretty sure people are doing that, right? Because imagine there's a lot of people with a lot of time on their hands, right? And a lot of brilliant people too. They have a lot of time, everything taken care of. I'm not just talking about the US, right? All over the world. A lot of really brilliant people, everything taken care of, and they're just poking around, right? And trying to find out, go to Russia or China or, just poking around trying to find little holes just for the heck of it. Find out, weaknesses and things like that. Maybe there's profit in there, but many are doing not just for the profit, okay? Just finding out if I'm able to hack in, right? Because that gives a high to many people. Just saying, well, they thought they were the castle of, Windrovia or something, but I hacked into them, right? So, and things like that. Even though they may not all go public with this and so on, but it's fun for lots of people. That's why there's a community of hackers, right? Who just hack for the hack of it, right? So that I don't know how we got started talking about that. Yeah, but that's, people are like that are doing that to all, anything you make publicly available, people are trying to go at it, right? They're going to take a crack at it. They'll find out any service, any API you provide. That's why you have all these very complex authentication mechanisms. Not because companies these days want to thwart hackers in that way, but I think it's more like they don't want to waste resources, right? Waste resources running hacker experiments, because obviously there's malicious attempts too, and attempts to prevent that. But I think also on a large scale, many hackers are just running experiments. on using free APIs. Right? Anytime you have a publicly exposed API, which makes a binary decision, right? If you have an API that can make a decision based on some, you've given them a choice, right? It's not a uniform distribution anymore, right? So you have a predictive, you've given them a bit or a switch, and then you can just group these things, many of these switches together, either temporally, meaning the same unit repeatedly fired in many milliseconds, so you get a pattern of bits, or you can have many of these units lined up in space. So not temporally the same, but you can get a bit pattern like that, a printer, parallel printers and serial printers, right? Going back to the ancient days of computer architecture. So bits are sent in sequence, or bits are sent 8 at a time. I think that was a concept, right? Going back to 25 years when I first learned about parallel printers and serial printers, I think that was the difference. In those days, I think when communication between devices used to happen either parallelly or serially, right? Parallelly meaning each byte used to be sent in 8 pulses, one after another. So the receiver had to group 8 pulses and construct a byte. So temporally separated pulses, and then the parallel printers, I think there was some advantage because they had 8 wires going into them, so not 1 wire. So they could send 8 bits in 8 different wires. So they were parallel, signals of the. I think that's what it was. I don't know. Interesting. Yeah, very interesting. At some point, right now, maybe it doesn't make as much sense to revel in the history of computer science or how many of these fields evolved over time. But after a while, I think you'll also, once you've played with many of these concepts long enough, you'll start wondering about, I think, how they first came to be, because many of these idioms you get to use, in computer science, it becomes second nature to you, and you forget. I would never have done it this way, but I still use it like this every single time. Why do I do it? Should I do it some other way? And you say, no, I would never have done it that way. Even now, if I had a choice, I would only do it this way. So how did someone actually come upon this way of doing it? Because I can't see any straightforward way of coming up with this automatically, like the human eye, right? So you can't see the human eye automatically coming together because there's many different pieces. Because even Darwin's, all the notes, this is the biggest challenge to him. I think he even wrote in his diary saying that the human eye is the biggest challenge to my theory of evolution, because he couldn't figure out a coherent set of things that could randomly come about to create this coherent whole. And there were lots and lots of theories put together as to how that the human eye, which is a very complex organ, came about from a single cell, right? Just through pressures, potentially through billions of years, millions of years, right? Because the human mind could only think through thousands of years, right? So millions of years, who knows what kinds of cosmic events could have happened on Earth, right? Or events could have happened, right? So random mutations, things like that. We can't fathom. But who knows, right? Who knows? Maybe there's a systematic way in which that could happen. Right, we may be able to figure those things out very interestingly, right? As soon as we get the ability, I think in a few years' time, when we're able to rapidly simulate evolution, meaning that computationally at least, right? So I think we would be able to see how a complex structure like an eye can actually come about, because we should be able to condense like 165 billion years. Or, maybe not 165 billion years, maybe it's like 300 billion years, right? Even before the dinosaurs, because dinosaurs had eyes, right? So we're talking about from amoeba or single cell organisms. So maybe like several more billion years, you condense all of that into 10 machine cycles. Or not 10 machine cycles, 10 milliseconds, right? Packed with, a horrendous number of machine cycles, right? Many, many computers, and would basically be able to simulate that. And we'll get real insight, right? So into what's going on, if that's useful, if that's useful to us. Hey, I'm sorry, we just stopped here. Okay, let's put a blank line between the constructor destructor and then all the methods we're going to create now, right? Let's create push and then pop, push and then pop. Push takes a string as an argument. Now I remember why we got started talking down that. Hey, anytime I get stuck in a tangent, please pull me back, okay? So we have a lot of stuff to cover, and I know it's a problem. I'm trying to work, not a problem in the sense, but I'm trying to work against that, okay? So that we get to cover this, and in the end of class, we can talk about a lot of shit, okay? So, all right, push, let's do pop. Yeah, string pop. Thank you so much, Lay. All right, so it's basically thinking a step ahead. Most of you guys are when you guys are typing. Yeah. So now let's also make string. No, pop shouldn't be constant. Push shouldn't be constant. Okay, let's say top. Let's give a top, and top should be constant. I think top should be constant. And then I think pop should be void, not. In fact, pop should be bool, right? Pop should be bool, and I'll explain. And someone should ask me why pop is bool. Okay, so later, not now. Right? Let's not go into the digression now. Pop should be bool, and it should not return string. Okay, and it's okay. And you can tell me, and someone should explain these signatures. Maybe I'll just give the mic over to you guys, and someone should explain the signatures and say, do these signatures make sense and why? Right? Are these three enough? Size. Let's do a size. So size should be an integer, right? So size t, and it should be a member right at the top. So public. In fact, you know what? No, we can't surface the value of. We can make size public because people can't change the size. Size should be automatically managed by push and pop, and then we should have a function called size that returns that value. So yeah, size. Okay, so we will need a size variable, right? Yeah, a size t size. Yeah, and what we'll do is we'll just call that get size, right? We'll just be consistent. No, I think we shouldn't call it get size because this is not a regular object, right? I think this should just be, again, this is conventions we're breaking, right? We're creating a class, and then this class has a member called size, and the conventional method when we have a member is to say get and that member, right? That's one of the conventions that we've followed in class anyway, right? So if you have a item, say get item. If you have variable, get variable, right? So, but size, we don't say get size because we're saying size stack. Here's the reason: we're implementing a stack which is very primitive type, right? So some of these primitive types, like I think stack, lists, maybe even trees. I think it helps to not use get for the basic things like this. I don't know, you guys can chime in, right? So we don't use, why not get, so yeah, put a comment there saying, why did we call it size and not get size? Interesting point for discussion. Not size, interesting point for Reddit discussion. Right? Why? Well, why did we not? Why call it size and not get size, right? Because there may be good reasons for calling it the other way. Right? Yeah. And don't get rid of the, why call it? No, why call it? Not did we, right? Why call it size? I think that's an interesting thing. Okay, yeah. Size to size. What else do we need? Can you think of any other methods that a stack should have? So you get a stack with a constructor, push things, pop things, get the size, get the top element. Is that the only, are those the only operations that a stack should allow on its members? It's so easy, isn't it? Stack is such an easy data type to implement, right? Because it doesn't give you a whole lot of operations. Even with a list, it's not so easy. Because a list, in fact, is very for a beginner, it's one of the horrendous data types to implement. Because as soon as you have a list and you say, here's an element inside in the middle of the list, okay, or some list operations, messy. If you don't know the right way to do it, it could get messy. Stack, it's here's a data item. It uses a list internally, but in fact, we're going to engineer this data item structure, this abstract data type, in such a way that all the hard stuff that you do with the list are not even options for the user, right? So the user only gets to do what we think are easy with the list linked data structure. Okay, let's implement these, right? Let's implement these, and then we can come back. Right. So what we'll do is to implement these, just copy all of the methods, everything that has open parentheses, triple click on line 6 and drag down all the way to line 13. Triple click there. Yeah, triple click on line 6. Line 6. We need the constructor and destructor too. And drag all the way to line 12. Triple click and then drag. No, triple click and drag. No. Control Z out. Control Z. Okay. Now triple click and then without triple click and drag. Triple click and then drag. Don't release it. Triple click and then drag. No, triple click and then drag. I don't know. Why doesn't it work for you? It used to work for me even on Windows. Triple click and then don't take your finger out. No, you double click and drag. You should triple click and drag. I'm not crazy about these methods, right? But I think these are cool tricks that you should learn because triple click, get the whole line. Now don't release it. Drag down. All right, all right. You practice in your own time, okay? You're releasing it and then dragging. That's why it's getting only that line, okay? If you don't release it and drag, it'll select multiple lines at a time, right? Those are tricks that, you know, will speed up your programming later on. Control Z out of it, Control Z out of it. I'll tell you what we need to do and you can do. No, Control Z, Control Z, Control Z, two times. One more time. No, one more time. One more time. All right, good. All right, so practice triple click in own time, okay? So we want to copy line 6 to 13, all lines from 6 to 13. Now you're going to get the, yeah, all right, good. Can copy that into a stacks.cpp file, right? New file called stacks.cpp.
While we're waiting, should the size member be private, and don't we also need like a data
Yeah, totally.
member?
Thank you. Who said that? Lay or Hiram?
Hiram.
Oh, Hiram, I wasn't looking at the screen. Sorry. Yeah. Make the size private. I'm sorry. Thank you.
Yeah, and then don't we also need a data member?
Yes, we'll come to that. We'll come to that very soon. Okay. Thank you, Hiram. All right. So yeah, size I unintentionally the data intentionally left out. Yeah. So and put a blank line before the private and public section so that we have two different sections. Yeah, and then get rid of the blank line before, in the public. Yeah, all right, that's fine. It's your style. Yes, you can leave it like that if you want. You had a blank line at the end. That's why I said. All right, that's all right. Let's go to your CPP file. Now these are the guys we need to implement. Now in front of this, because this is in a separate file, the first thing we'll do is go right to the top of the file and hash includes stacks.h. Hash includes stacks.h. Now, in the process of doing this today, what we'll do is I'm just doing the shell of it and saying these are the methods we need to do. But most of these, we're just going to put comments there, and you guys are going to do the rest, right? Even if it takes the rest of today, maybe other time on Thursday or before Thursday, guys get together. You're going to complete the rest of it and then share it on Reddit as usual. Okay. All right. Now hash include. Okay, that's good.
Careful, because the stack.h, it's not stacks.h, it's stack.
Oh, in fact, I think it was strstack.h. We'll rename it now. You can take the opportunity to rename it to strstack.h. Thank you. All right. So I think the class should also be called strstack. Yeah. Thank you. And then, is that right now, Hiram? It's the same, right? Yeah, looks all right to me. Now. Yeah. Okay. Now, also, what we'll do is double click on the word strstack. Double click on the word strstack, and just the word strstack. Oh yeah. Okay. Copy that into your clipboard. Now paste that in the front of every single function of function you've got, and put a double colon after that. Right. So go to the beginning. Yeah. Paste that there, and then double colon there. Now here on the next line, I think the syntax of C++. I think the syntax calls for the tilde to be before. No. I think this is correct. This is the correct syntax. Okay. I keep forgetting. No. So the void. Yeah. Here, the void should come before. Right. str should only qualify the function, not the return type. The function. All right. So what this means is that these are all functions we're going to define. Okay. This way, we'll prevent the least number of errors, right? Copy and paste, and then never copy and paste from a PDF. But since we have an ASCII file, copy and paste, that's fine. Now, again, go to the beginning of the constructor, and then change the semicolon. Go to the semicolon, right? Backspace. Now, space. Yeah. Oh, you're not putting a space there before the brace. Okay. All right. Now go to and put a blank line after the closing brace. All right, and do the same thing to all the other functions and put a to-do in there. Put a to-do or something, right? Put a to-do in there. Those are the things you're going to do, right? Well, we'll do some of those and you're going to do the rest, okay? All right, you're going to do the rest do everything like this. Oh, you don't have a parameter for push? You just say string s.
Made it. Okay.
Put it there too. String s.
Does that need to go in the .h file as well?
No, even in the other one, you say string as, yeah, and you can also say const string as. You're not going to change it, but you can just to make sure that it's a constant. Yeah, you can put a const in front of the string, yeah. And even the other one. All right, so you're going to do all the other ones too. Oh, you did bool here, not void for pop? Put a void. I think you had a yeah. Make it a void for now because we haven't decided whether to make it bool or not, right? So eventually you'll make it bool, I think, right? For now, let's keep it void. Yeah. All right. Okay. Right. Is this okay, guys? We're just setting up the slate for you guys to fill in. Yeah. Okay. Great. Thanks. Size. Now this is really easy, isn't it? Let's just fill out size even while we're doing it, right? Just don't do what to do. Just do it. Do it. All right. Now, in fact, you can do that. You can even do that inline, right? Just get rid of the function and do it inline, right? So let's not do this function out of line. Do this inline. Get rid of this function from here and go to the header file and put it inline, right? Get rid of the function here. Get rid of the function here. Yeah. And then in the header file, just do it inline now. In fact, what you're going to do is many of the functions in that file, you're going to make it inline here eventually, right? But now we'll do it. Yeah, get it in, do it inline. Return size right there.
Also, can't that function be a const function?
Thank you. Yeah, very nice. Very nice. Thank you, Lei. You can make that const too. Size is also const. Yeah, we can do one more, right? We can do empty. Empty is empty. That could also be const. Right? And you can also make that inline, right? Is empty. Well, right now, let's not make it inline, okay? Let's not make it inline right now. Yeah, let's not make it inline right now, okay? All right, we're going to get to that eventually. Okay, all right, let's go to our header file. Yeah, we need an isEmpty here too. We need a isEmpty here also.
A what?
Right, isEmpty. You just insert in the header file, right? So put it in the other one.
Okay.
Bool isEmpty. And this is also const, right? Because it's not going to change anything. It's just going to say yes or no. Yeah, and then close it. And now, for the to-do, under the to-do, say something here, right? Under the to-do, hit enter, and say return true. And then against put a comment there saying this is a stub. You got to change it when you finally when you flush this out. This is a stub. You got to change this. So does everybody understand what that is? These are basically tools that we do, right? So once you get to programming for your own fun, right, or for pay, these are things that you'll be doing a lot of. So might as well start getting used to it, right? So when you start putting a big project together, you'll write a lot of these functions, and after you write the shell, you'll know, all right, these things can be formed out, right? So this entire section can be given out to a contractor. This thing can be given out to Robert. Or that so you'll chunk these out, but to see before you give these things out, right? What happens if you give these things out and everybody comes back to you with their correct implementations, and you put them together, and then you find out that your overall design doesn't work, right? So you just wasted the time of all of these contractors, all of these people, right? Because most of these software engineers, good software engineers, I'm not talking about run-of-the-mill software who don't care about what they do, right? If you get good software engineers, they're not working for pay. They're not working for the money you give them, right? They're working for something that they do that will eventually make the life of someone easier, right? Someone on the road who says, wow, look at that. I can actually speak like a normal human being and get that understood, right? And they're on a bus and they happen to hear someone else say that gives them a high, right? So those are the things that people are programming for. So if you can't get those guys to program for you, or you can say, do this, guys, and once you get that done, I'll figure out if my stuff works or not. Right, so nobody, you won't get a engineer work their salt come and work for you if that's the attitude. So what do? So as Linus Torvalds, right, as someone who's putting together a bigger system, the way you do it is say, all right, so this thing is so big that I can't do it myself, right? So these bits, other people have got to do it for me. So, but I can't wait until those guys get back to me. And also, those are going to be such good engineers that I can't waste their time by asking them to do things which I don't even know how to put together. So let me first make sure I have a shell in which I can put together make-believe versions of things that they do, right? Maybe horrendously engineered, even incorrect things, right? I just want to make sure that out of 10 trillion use cases, one use case actually works. meaning that all these functions return A, B, A, 2, X, and so on and so forth, right? In some use cases, these are written, so I'll just make these functions return stub values, which are, enough to make my big machine work one time, right? But it's going to work, not going to work all the time. So those are called stub values, and you put those together. And when you're convinced that the big system works with these stub values, at that time you say, okay, now all right, I know it works. I'm going to take my isEmpty function and I'm going to contract it out to someone who will basically look at the data structure, look at all the resources, and figure out is it okay? Should I return true or false? This is going to return one bit of information, but in order to return that one bit of information, they had to do so much work, all right, and which you can do yourself, right? And you're paying like $1 million or more for getting that one bit of information from them. So how cool is that, right? And so being a software engineer, you can do that kind of thing, right? You can say, right, I can do this for you, but make sure it's worth it. And essentially that's what you're going to do. And so we're going to put in stub values for as many things, right? So under pop, you're just going to say return. So just say return, right? So string stop, you just say return a blank string, right? And put stub values everywhere. No, you can't say return. Yeah, thank you. Done? Yeah. All right, now let's go to the constructor. So what we want to do here is I just describe it using, fists, okay? It's very easy. So when I ask for a new stack, I just get a box, okay? It has nothing in it, empty. It has something called, this is the beginning of the stack, okay? And it's just going to be a null pointer, okay? So let's just say, so it has nothing, it has, let's say my fist is a pointer. My fist points to a location of an empty room in which I can put stuff, okay? And when I ask for a stack, I'm going to get a fist that points nowhere, right? In fact, it points to a locked empty room. So that's a null pointer. So that's what my constructor is going to give me. Does that seem like a reasonable thing to do in a stack? Yeah, okay. Which means if I go with a null pointer, meaning that I don't have to, let's say, allocate memory in my constructor, that relieves me of a great headache, right? What is that headache? If I don't allocate memory in my constructor, I don't have to worry about something. Yeah, I don't have to deallocate that in the destructor, right? So so the only thing I need to worry about is someone takes a stack, makes things with it, and then goes away without emptying it, right? And that's their problem. So we have to make sure that people know that, okay? Eventually you can just create a stack. In fact, even here we can do that, right? Even here we can do that, right? So if it's not null, we can destroy it, right? In that is called defensive driving, right? So when we start to learn to drive, we're just learning how to control the car, right? Even that's really hard, right? I remember when I was first behind the wheel, it was really hard. I was so scared to press the accelerator because I was not used to the acceleration, that kind of speed, right? So initially like that, but eventually, after you get experience, and then you say, well, you go to the driving school and you make some silly mistakes. You say, well, I'm going to give you a license, but you'll do much better after you do some course. What do they call it? So they called it defensive driving course. Okay, they said, if you're interested in avoiding the kind of things that you did, okay, you can do this course called defensive driving course. And this is the first time I ever heard of this course, right? You can Google it and you can find a lot of information about it, right? So a defensive driving course. I don't know how many of you have heard of this course called defensive driving course. Right? It's going to be totally useless in a few years, okay? Right? In a few years, who's going to be driving a car, right? 5 years from now, nobody's going to be driving a car, except, enthusiasts and, the corner cases, right? People are going to be, hopping on instant cars, right? So, cars are going to be a service, like, Gmail or other services, right? So I'm going to pay with my Google account or Apple account for these things. So, but now you can find out, maybe you can still find out, historically, this is what. So defensive driving is when you can drive according to the rules, when you can program in C++ according to the rules, right? So you can drive according to the rules, but you are going to compensate for mistakes made by other newbie drivers around you, right? Those guys around you who don't know how to drive properly, they're going to be driving, they're going to be running into you. So you're going to be compensating for other people's mistakes. So how cool is that? That is the goal of defensive driving. So once you get to be a certain, I never got to be that level at driving, right? To learn about defensive driving. But that's the suggestion they gave me. So once you get to know, right? So, and you want to protect yourself against even more serious errors that you don't cause, errors that other people cause, right? So then you say, so all right, so I'll do defensive driving so that I can. So then you say in your programs, in defensive, I don't know why do we defensive programming. Defensive programming is when, right. So you try and say, I'm going to create a data structure which has been defensively programmed, meaning that not only is this data structure self-contained, it will do all the right things when you ask it to do, but you can also use it in the wrong way sometimes. And it's not going to kill you like other people, right? So you can still use it in the wrong way, but it'll be tolerant, meaning that it'll try and compensate for stuff that you didn't do yourself. And we take it for granted all the time, but all the technology that we use today, right? Every single thing has got so much defensive programming built into it, right? So in fact, many of the programs we use today, they're not defensively coded only because they're written by newbie programmers, right? Most programmers just say users are, I think this is the motto in programming, right? You can make the product foolproof, but you cannot make it damn foolproof. I think that's, it used to be very popular a long time ago, meaning that it's impossible to protect against people that are going to make it, they're hell-bent on breaking it. So you can, but what programmers are trying to do, will try and take care of all of the users who just, who make, mistakes without knowing, right? We can't protect against malicious users who are trying to break into it, but at least the common mistakes we'll try and guard against, right? That's what is, guarding many of the, that is, I think, the governing force behind most of modern technology development, I think, is that technology is getting more and more defensively developed, in a sense that it is compensating for more and more of human errors. So the best technology out there is going to be a technology that can compensate for most kinds of human errors. So we just don't have to worry about anything, right? So to take anything, for example, right? Speech recognition. I could ask Google something and mispronounce something completely, right? So humans may not get it, but Google will get it, right? Why? Because it matches against all the right kind of data and things like that, right? And it makes all the right connections. So I think defensive programming gets us a long way, right? And in fact, the more errors, the more of these we can handle in our code, programs get better, as well as the usability, gets better too, I think, right? Of course, I mean, there's a way we've got to exercise this judiciously, but that will come through experience. But I think tolerance to programmers, the tolerance to users, right? Initially, when we start programming, we all start feeling very special, that we can program, other people can't, and we can create things, other people are users. And so I've seen programmers who have that kind of programmer's ego, saying that, users are beneath us, right? Users make things that we create. But those are programmers that will never become real programmers. They can't cut it, right? Because unless you put the user above you and look at yourself as serving the user rather than dictating to the user what they should be doing, right? Even companies that appear to be dictating to us what we should be doing, if you look closely enough, they're not dictating to us what we should be doing. They've basically spent years and years trying to figure out what we want to be doing, right? They've got lots and lots of data. Most people don't know what we want, right? So because, you look at ordinary Joe out there, right? They're going after a million things. They don't know which one is going to give them happiness. So, and how do you find out? How do you find out, right? So the one way to find out is to basically detach yourself and look at the data objectively. And most people, even scientists, even published scientists, professional scientists, people on TV, celebrities, they see them all break down when it comes to certain, cultural barriers that make them feel special. They'll say, let's not be scientific anymore. So people can't, they're pursuing too many things and they can't figure out. So you look at the data and then we say that, this is the right sense of aesthetics. This is what will make you happy, right? Just go down this path. Trillions and trillions of people have found happiness this way. Try it first before you try your own way, right? If it doesn't work, do it the other way. But there are people who say, just because, they say do it this way, I'm not going to do it that way. But that's a bad way to do it, right? So they say do it that way, but do it with an open mind, saying, well, I'll try it out. If it doesn't work, I'll do it another way. That's okay, right? So I don't know where we're going with that. Yeah, defensive programming. I don't know, defensive programming. So yeah. So let's make it completely defensive. And So in our defensive programming, what we'll do is that you can create a stack and then lots and lots of, this is an example of defensive programming, right? In the destructor, put a comment in the destructor. in the destructor. Saying we're going to be defensive. We're going to be defensively programming our destructor. This is an example and a comment, and so we are going to be defensive. We will defensively program a destructor to release all allocated memory in the stack, even if the programmer does not pop all the items before the stack is deleted. Does it make sense? Yeah. And that's possible, isn't it? So all I'm saying is that if something is possible, why don't we do it? That's all, right? So if something is possible and it's going to ease the life of a programmer, well, so can you guys do that? So all we're going to do here, let's go to the constructor, and in the constructor, we're going to do, let's say, first node. All right. So now we know what our stack needs to contain. So go back to the header file and say, let's create an inner class called node. Yeah, inner class meaning inside of stir stack. Yeah, class stir stack. Enter after that. Actually, let's put it in private. Yeah, put it in private. Say class node open close. Brace. Yeah, brace. Enter. Now you say string space data. I think this should work. Okay. Semicolon and node star next. Next line. Sorry. Next line. Node star next. Now we don't need to worry about making this private and public and so on here, because we'll just keep this a very simple class. Because it's already inside the private method. Does that make sense? Yeah, it's inside. So in fact, we'll go one step further here. Okay, we'll make it even simpler and turn that class node into struct node, right? Which is basically, and remove the parentheses. Yeah. Okay. All right. So we have a data type there. Right? That is called a node. This is confusing. We'll just go back to class. Oh, turn the struct back to class. Okay, turn the struct back to class. Yeah, because I think a struct is nothing but a class in which everything is public by default, right? In our case, it didn't matter because everything was inside the private section of our class. That's why we did that, right? So unnecessary digression. So node star, the capital N for the node. Okay, semicolon right there. Semicolon after the class. Not there. After the brace, put a semicolon. Yeah, semicolon to end it. All right. So we have a, and then on the next line, you say, no, we don't need that. Right? We just need a class in which you have those items. That's all. See, we don't. So we have basically a class. We're going to use the freebie constructors and everything, right? So on the next line, you say, maybe we need a constructor, right? We'll do that. But all right, on the next line, you're going to say a node. What do you call it? Yeah, star. No, space star, and then let's say first. What do we call it? First or top or first? Yeah, first node. I don't know, first node. Yeah, first. Let's call it first. Okay, now in our constructor, right? Now, we can just say first node equals null. What was it? Did we call it first? First node or first? You can get rid of the to do because we're actually filling it. A null pointer, LPTR, NULLPTR. Yeah. All right. Yeah, I think you called it first node. Lei, did you call it first node or first? Oh, you just call it first. Okay. All right. Yeah. All right. Now you can actually say, yeah, all right, first equals null pointer and size equals 0. Okay. Is everybody okay with this constructor? All right. Now in the destructor, what we're going to do is, all right, I'm going to put a comment there and you guys can fill it in. All right. So, and tell me if this is okay. The comment is going to say, right, unlink the first node, keep on unlinking the first node and deleting it until the first node is null. keep unlinking the first node and deleting it. Actually, we should, yeah, I think we should call it the first node. Keep unlinking the first node and deleting it until first node becomes null. Right, and put a blank line before that. Okay, put a blank line before that because that's what you guys are going to do. Yeah. Does that make sense? So I, got a stack and I pushed a lot of things in it, and then my stack went on scope, right? So the destructor kicks in and says, "Hey, I got a stack that went on a scope, but it's actually got a linked chain in there, and that's allocated memory." It says the first node is not null. Okay, I'm going to take the first node and free it. But before it does that, it got to take the first node, grab onto the next, and then free it. Okay, and then make the next the first node again, and then it can do the same thing. Keep doing that. Yeah, until at some point the first node is null, and it says, "Okay, I've deleted the entire stack," and then it can go. Is everybody okay with that? Okay, so that is the basic dance. Okay, so like a ballet or some complex performance made up a lot of little moves. This is the basic step. Okay, so this is it. All right, so you take the pointer, has another pointer inside of it, and and you have to be super careful because there's no other pointers anywhere. Okay, those are the only 2 pointers to those 2 guys. So if you lose one, you're gone. Okay, so hold on to those for dear life. Okay, now you let go of that. Okay, and then move this and grab onto that. Okay, now this one is free, you can grab onto the next one. So this is like a monkey bar when you're learning a child monkey, doing the exercises, right? You got to do that. Yeah, and that's essentially what you're going to do. Right, so anyone who's doing that in the gym, they can do exactly the same thing with stacks. All right, so that's what the destructor's got to do. Everybody okay with that? You want to do the destructor? All right, let's go to push. Let's go to push. In fact, let's go to pop. Let's go to pop. Okay, let's go to pop because pop is really easy. Yeah, and I'm not going to implement it. You're going to implement it, okay? And you got to make sure that there's no memory leak and so on, okay? So on the next line, what we'll do is I'll give you a hint, right? Comment saying, we'll do the first line, okay? If first node is null, return false and change the void to a bool. Now we know what to return, right? If the stack is empty and you're asking it to pop, it's going to return a false. So that we can identify a clear condition when it can say, no, I can't pop anything because, on a heap, there's no other reason. Because like I said before, the computer will die or slow to a crawl before the operating system says no more memory. So you can keep on pushing, and you're not going to see it, right? It'll just slow. So I think the way to make pop fail is you say that here's a stack, but the stack is empty. Then the stack can't then it can't do anything. Hey, LA, you just disappeared. Hey, what happened to your screen? Oh, you have it here. Yeah, I say I look to the all right. All right. So pop. Yeah. If first node is null, return false. Oh, I see. Oh, you're going to do everything. That's fine. Okay. Otherwise, okay. On the next line, say one more comment. Yeah, no, that's fine. No, do it on your own in your own time. On the next line, hit enter after the false. Yeah. Else. Unlink the very first element, return it. No, unlink the very first element, free it, reset first, and return true. Reset the value of first. Yeah, reset the value of first and return true. Now, that's all we have to do. But why do we have to do this particular sequence of steps? Right? That is worthy of discussion, right? So you can take that discussion to the forums. In fact, some of the 2B students might also benefit from this, right? Maybe not because they've moved on from quest number 1, but this is a question that's asked in 2B's quest number 1 to say, so some of these things. So all right, so is everybody okay with what pop does? Yeah. Now all we need to do is push, right? Push is going to take the thing that you give and create a brand new node and stick it on the very first element and adjust and pop. No, the first should now point here, and what used to be pointing at first is now pointing to the next of first. Yes or no? We got a new bead and you're going to stick it to the middle, the beginning. That's all, right? So all right, so now what we do here is put a comment saying create a brand new node whose data is as right, and whose next element is the current first element. And then the current first element should become this element because it's stacked, right? Because you push something in, now that's the first. You push another one, that's the first, right? So it keeps getting in. No, you see, there's no way of getting to the elements inside the stack unless you go through the first element. Yeah? Really cool, isn't it? So that's the power of stacks. It can hide information and can also surface them at the right time and so on. Yeah, okay, that's no. The current element should become the current element. Hang on. The current first element should become the new element. The new node. Right? The current first node should become the new node. I don't know. You can word it however you want. Okay. Does that make sense? That's all POP needs to do. And think about it, right? We're talking about 2 lines of code, right? Everything we're doing here is just 1 or 2 lines of code, and we're done. 2 lines. So this entire class is a couple of lines, each function, and that's it. How many? 32 lines, 40 lines, done. Okay, everything is done in the stack. Dynamic stack, unlimited size, right? So you got it. It's different from the system stack, right? The system stack is limited in size. Even when you start a program, you get a stack that's limited in size, but this stack is unlimited in size, just like STL stack. All right, good. Pop is done. What else do we got? Top. Top is const. You can do that easily. Yes. You guys want to do top on your own? I won't even talk through this, right? Oh, you know what? What happens if the stack is empty and you try and do a top? Yeah, good question, isn't it? Right. So many different ways of handling that situation, right? I don't want to throw an exception, right? Because we haven't covered exception. Yeah, exception is nasty, right? I don't want to throw exception. Well, here's my general feeling is that I never try and throw exceptions unless I absolutely have to, right? Because exceptions have a different way of doing things, which is different from the way we do it here. And why mix 2 different paradigms unnecessarily? And so don't do exceptions. How do you do it? So, and that's again, great discussion, interesting, useful posts. We can have lots and lots of interesting discussion here. How do you handle a situation? How does C++ do it? Right, in C++, in C, 0 is the, or n is a /n is a new line character, right? So what happens if you want to insert a slash itself? How do C, so that's called an escape character. So that's how you escape certain situations. And how do you do it here? What happens if you want to, what happens if I want to actually insert a blank string? So what you need is a string sentinel that says the stack is empty. So you need a special string that says you're trying to pop from an empty stack. If you don't want to throw an exception. Yeah, am I making sense? Is that all right for all of you? Yeah. All right. So not only Alexandria, right? So everybody, some of you I can't see, right? Jared, I can't see you, man. Fernando, you're here now. Fernando?
Yes.
Okay, good. All right. Are you okay now? You're okay?
Somewhat, yeah. Hanging on.
Can you concentrate?
Yeah, I can. Yeah.
Okay. All right. You got to watch all the videos. You got to watch the videos, okay?
Yeah.
And work through the code. Work through the code also. All of you. Yeah. Jared, I can't see you. Okay, I can't even hear you. Okay. What was I saying? Yeah. So we got to figure out how can you tell? How can you tell if it's an empty stack or not by doing? Can you do a top? So one way is to say one way is one way I put a comment on top of tops, right? So let's put a comment saying one way to handle the situation of popping from an empty stack is to put a comment in the documentation, warning the user, saying the results of this function are undefined if you try to examine the top of an empty stack. That is the bad way of doing it. If you ask me, that's a bad way, right? So a slightly better way is to have a sentinel and say I have a special string that is returned if you try and pop from an empty stack. Yeah, also, that's so messy, right? It's better, but it's messy because now you're saying user cannot push that special string. What if the user wants to push that special string on the stack? Then the user has to distinguish. right? So you can say, oh no, then go back to the other way. So it's undefined. Before you call top, you got to call is empty. That's a pain. So either way, it's a mess. So the other way there is another way in which you can handle this cleanly. Okay. So I don't want to, there's many ways in which you can handle it. So I've told you 2 ways, brainstorm other ways, right? Brainstorm at least 2 or 3 different ways in which you can handle it. You can, discuss it on Reddit. And who knows, right? Maybe you come up with a completely new way of handling the situation, which other people haven't thought of, which doesn't use exceptions, right? Maybe some guy in the C++ standard happens to watch it and say, hey, let's try and see if we can do something like that, right? Who knows? You can never rule out the possibility that, many brilliant, I think many brilliant strokes of genius have come from students, right? Even surfaced through professors maybe, but they were, come from students, or maybe students. Today, you don't even have to surface them through me, right? If you have something, a brilliant idea to say, just go and make a Stack Overflow post about it or something, right? So even though 100 people may not notice it or make disparaging remarks, there's a chance that if you said something really nice and sensible, someone who knows what they're talking about would read it and say, hey, wow, what a really profound observation, right? And actually use that in their code. And it makes a difference for humanity. So you should never feel free to, you should never feel reluctant to share these ideas, right? So these are ideas that you can, and these problems, right? So I don't have the solution, let's say, and you're going to figure out the solution. And maybe I give you the wrong solutions, right? Maybe the 2 that I gave you are wrong. Maybe they're not supposed to be used, because you can identify situations in which they would be dangerous to use, right? Or not even the best idea, right? So those are things you can talk about too. Say, here's why using a sentinel is bad, right? Here's why, and things like that, right? Or here's why, documenting it is bad. You can say, you go to the Java documentation, or even C++ or C documentation, you do a man page, right? Many functions you'll see, right? Don't call this function like this, right? Undefined, right? This function is not strings, multi-thread safe, or, but that's understandable because ancient days not multi-threaded. But certain functions you still see. Modern functions, it's undefined behavior. In this case, don't do it like that. No, that's not the right way to engineer a function, right? A public function like that should be robust to all kinds of input and basically return sensible answers, right? Don't say don't do it, but say if you do it that way, this is what you're going to have, right? I'm not going to be able to do it for you. That's, people are able to accept that. So most users can accept it if you ask them to do something and they say, I can't do that, and you tell them, no, I can't do that. That's fine. Okay, people are happy with that. But if you, if someone comes to ask you to do something, and you either do a bad job, or you agree to do it and don't do it, or all those things are things that don't make you endearing to other people. Yes. So and our functions should be just like that, right? And shouldn't say I won't do it for you, right? Or you should only use me this way, or if you use me another way, I'm just going to explode the whole world, right? All of those are bad responses. And instead you say, I can deal with these kinds of input. Anything else, I'll just return it to you. I'll say false. That's all good, right? And people are tolerant. That's what I mean, right? What we want to do is design things that are known to make people tolerant with you, right? So if we make things that are bound to make people complain, then people will complain, right? It's their right to complain, and so we want to design things to make them, tolerate us. All right, so top. So you can, put a comment there saying discuss ways in which you can, put a comment saying discuss ways and implement, right? So put a comment saying discuss ways we'll say next line we'll say to and implement them, right? Discuss ways to handle the situation when the user wants to push, when the stack contains discuss ways to handle the empty stack, the situation when the stack is empty, handle the empty stack, handle an empty stack, right? I think that's good, right? Yeah. And on the next line, you can say one way is to use a sentinel, just to give a hint, right? One way is to use a hint. Again, useful point, right? Lots of points here, right? So coming up to week 12, and also I'm preaching to the wrong crowd, okay? You guys probably don't need these points, all these other students who are not here need these points, but you are linked into them, okay? Because student group. So you got to get the message across. There are so many opportunities where they can get extra, because, you know, I can see most of the students are not going to get more than a half of the participation points, right? 15 points for participation. Most of the students have lost 7 of them already, right? Because they're not participating in class or on Reddit and so on and so forth, right? So getting to the last of the, I'm throwing some opportunities here, throwing in some opportunities to give those students an opportunity to catch up, meaning even an opportunity to get the lost 7 points. But in order to get the lost 7 points, they really have to make some, you know, profound observation here, saying something that is really worthy, right? On that point. Here are 2 ways I've thought of in which we can handle that sentinel situation, right? That means if I see something really nice there, that means, okay, that is totally worth like 10 of the 15 for participation points. Even then, right? I'm not saying it's worth 10, but it's possible to get a lot of points, right? There. So these are a lot of things like that. So I just pass the message on to all the other students, right? And despite these things, right, it's possible that you just want to pass, and that's okay. I appreciate that, but I'm just talking to the people that want more than a pass, right? Who want to master the language or major in C++ or major in computer science, right? These are the opportunities for you to get more points. Does that make sense? Have we covered all of the methods that need to be implemented for stack? I don't, my input is not needed anymore. That's why for this class, for this thing, is there something that no, I think we've pretty much done most of it, right? Is there anything that is left to do? Because you guys can, what time is it now? 9:42. Yeah, I think you guys can wrap it up in 15 minutes, right? Before the end of class, easily. Yes or no? Because I'm looking at this, probably no more than 10 lines of code altogether, 10 lines, right? And I'm not talking about big ass lines either, right? I'm talking about, you know, 4 and then the body of the 4, right? Or maybe, you know, one line, 2 lines, 1 line, 2 line, total 10 lines. That's it, you're done. And you can write a main in which you create a stack, push a lot of stuff, pop, pop. That's another 10 lines, 20 lines of code, 20 minutes. You guys able to do it? Yeah, you can do it, right? If not, you can call me. I'm just going to be around. I'm going to be here. Maybe I'll just go, yeah, and take care of something. But are you guys okay? Can I just leave this in your hands? Yeah? Okay. So just implement the rest of it. Share the code on Reddit, but I'd like to ideally see it completed in class. Okay, run it in class. And if you are bold enough, try and do some timing experiments with the vector kind of stack, right? And before I leave, let me leave you with this one problem. If you can also do a stack with an array. I'm not talking about vector, okay? Using a vector is different. Talking about native. No, even vector is fine. A stack using a vector, which is what you're going to do in Quest 8, a vector-based stack, and you got a linked list-based stack. And again, it's a singly linked list, right? Not a doubly linked list. We've got only one pointer. Now, suppose we have this extremely unrealistic request, okay? That's why this is not implemented in all the stack implementations out there, right? Suppose someone says, I want a single method which will reverse a stack, okay? So take a stack, okay? It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I cannot get to 1 until I get pop 10, 9, 8, 7, right? I want to reverse it completely, bam, right? In one, bam, like that, in O of n, in linear time, like that, or in constant time. Forget about linear time. I want to do it in constant time. I want to, right? So can you do it in constant time with the linked representation we have? And can you do it in constant time if you have the vector representation, right? And the challenge is to do it in constant time, not in linear time. Because a linked list you can do in linear time, right? All you have to do is take that and push it on a new stack. Take that, push it on the next stack. So that one is going in the, so just reverse it. Just walk it off. Yeah, so linear time. But what if I said, no, I can't do linear time. I want to reverse it in constant time. Can you do that? So with some implementation tweaks, you can actually do that with a, you know, with the vector stack implementation, but it's unlikely, right? How many people are going to ask you to reverse a stack, right? Other than for, you know, pedantic educational purposes, I don't think so, right? So those are things you can do. Can I leave this? Yeah. If you get to that, you can get to that place and you can play with this too. Right. I'm gonna be around. Okay. I'm just gonna be here. If you just need me, just call, okay, Prof, and whatever it is, just call me and I'll come back. I'm going to be listening. I'm going to be within earshot, okay? And in fact, again, let me just turn it around so I'm not in front of the screen, okay? So it's over here. You can, all right, there you go. Can you see my screen at all? Yeah, all right, so there you go. All right, so I'm going to be here. If you call me, I'll come back and turn it around. Otherwise, just feel free to talk and complete the rest of that code.
Can we start with is empty? Because that's really easy.
One thing before we start, actually, I just realized that we probably didn't use using namespace. And so for before every string, you need to put std :
Oh, yeah.
And I think that's probably better to just not use using namespace sometimes. But we can use it in the CPP, but I think in the H for sure, we should probably just put std : string.
And there's one more, line 16. Okay, is empty. That should be easy because first will just be null pointer. Oh, size is 0. That's even
Yeah,
better.
return size == 0.
Okay, yay.
I don't know why I used the method size. Like, why did I do that? Whatever. Top is pretty easy too, because all you have
Yeah.
to do is like just check if head is a null pointer, and if it is, return the sentinel string, and then else, which is you don't need to write, return head data.
Yeah, it should be good.
Oh, sorry, I have different names in mind. Oops.
I'll have to go in 3 minutes. Sorry, guys.
Oh, you know about single line if statements, right, Lei? Or how do you want to be called?
Is it data or? And do we have to do arrow or a dot is fine?
Where? Oh yeah, it's the arrow, because first is a pointer, so we have to use the arrow to like dereference and then get the stuff from inside it.
Okay, cool. Pop should be good. Another if statement or if it's empty.
Yeah, the biggest pop is my biggest one. It's 6 lines of code. All my others are 2 or 1, including the destructor.
That's nice.
Yeah. Actually, no, I'm still working on push.
Okay, so period. First has to, yeah, you got it. Do we have to store it in a temp or to delete it? Or are we
Delete
not?
for pop?
Yeah.
Yeah, you have to have a temp.
Okay, can we have a temp?
So yeah. Oh yeah, you could use is empty, I guess. I just didn't like using is empty because it's not like directly connected. So I just used if head if the first is null pointer.
That's true. Then you're sure that first next won't grow. So I
Yeah.
like that.
Exactly.
But it's not a big deal.
It's not a big deal because if size is 0, then it should be fine, right? Because if we manage the size variable properly, I just like to be sure.
If size is correct, yeah.
So yeah, no temp
Alright,
equals first.
Now we can delete temp.
Yeah, we can just straight up delete temp. So I originally, when I was first writing this, tried to like make temp head first next, right? So that I could like store the pointer to the next one and then reattach it. And then I was like, wait, that's stupid. I can just like attach and then just remember the one that like got detached, right? That's still attached but like shouldn't be, and then I can just delete that one. And I'm like, why didn't I do this the first time? It's literally.
It sounds like you were doing like a list where like you were removing.
Hmm?
Oh, nothing. Why would we use free instead of delete? Because I've always been using delete.
Wait,
I don't know
there's
how
a
to
free thing? Oh, okay. So yeah, you want delete and then it's nothing. It's just delete temp, like 2 words. It's a special function.
Do we need to do anything else? It says
Yeah, we
reset
do. We need to increment
value?
size, decrease size.
Oh, yeah.
Yeah, okay. So other than that, I think that's pretty much it for pop, right?
Okay, cool.
And then I'm working, I think I just finished push. It's like 5 lines. Do we want to return anything for push? No, right?
I don't think so.
Yeah, 5 lines. Size plus plus. I forgot the plus plus. Okay. Okay.
We have no methods in Node.
Yeah, we don't.
How do we initialize everything?
How do we initialize a node?
Oh,
I think we just use in the CPP node, new node, or whatever you want to call it, node star new node, right? Equals new node.
And then we can do new node data. Or, yeah.
No, like just
Because
straight
we have to
new
set
node.
the data.
Oh, are we gonna make a constructor for node? Is that what we're gonna do?
Yeah, I think that's what Wesley was asking.
Okay, so we can make a constructor, I suppose. I just don't see really the point of it, except for maybe saving us a tiny bit of lines of code. Oh, it needs the star before new node and when you're initializing it. And there's
Yeah.
no parentheses.
And then you can do arrow data.
Do you understand? Oh, yeah, the arrow data. Do you understand why it's just like new node? Or is that confusing?
I think I kind of get it.
Okay.
I mean, you can use parentheses, which is
I mean, you probably could, but wouldn't
why
that like
I'm
call a
confused.
default constructor? I suppose it wouldn't be a big deal since we're setting everything up right here anyways. Nice. That looks perfect. And we don't need a return. Do we? No, we don't. Yep. And then we just need the destructor, right? Have we written that? Okay, so I found this funny little thing. I just did while pop.
Yes, because it returns Boolean.
It returns
So-
a Boolean, so you don't need to check anything and you can just go while pop.
And put a
That's
comment.
it. Just while pop and then you just while pop and then semicolon. That's it.
Beautiful.
And then you can just delete a head because you still have one left over like that. Or will you? You'll have head as null pointer, right? So I guess that doesn't really matter. Does it? I don't know. I feel like we need to delete it, but I guess it doesn't hurt to delete it.
So, guys, I've got to go. Looks good.
Yeah, we're pretty much
think-
finished.
Yeah,
Yeah.
delete. Do you think we need to delete head?
No, if
Sorry,
there's one
first-
element in the stack, you pop it, and then it'll be first will be null.
Yeah, first will be null after the while pop.
So I
That's
think
for
we're
sure.
fine.
I don't. Do you think that's first will be null? It'll be a null pointer. So yeah, I guess it is fine. Okay,
Very
then I
cool.
guess we're pretty much done.
Yeah, I guess I'll share it.
Yeah, the longest one is by far pop. Well, I guess not by far. It's pretty close.
And yeah, I'm gonna head out and see you.
Okay, I guess I can go too, most likely.
Yeah, I think it's the end of the class anytime. Anyways,
Yeah, it is.
all right, bye.
Anand? Anand? Anand?
Hey, yes.
Okay,
I'm
okay.
back. Hang on.
Uh,
Yeah. Oh, everybody gone except you and Fernando? Hey,
yeah, we
Fernando, are you
finished.
here to talk to me? Fernando, are you
Oh.
here?
Yeah, I'm here. I'm here.
Are you here to, are you waiting to talk to me, or are you just hanging around?
No, I was gonna talk to you. Yeah.
Oh, okay. All right, cool. Yeah, well, let's, yeah, Hiram is still here. Let's see if he has any questions first.
I just have a question about like a certain comment that you made in the code for Quest 9. So
Quest
if he
9?
wants to go first, yeah.
Oh, in the code for Quest 9.
Yeah, in your starter code. Like you made this comment that said that all of them except toString and one other, I forgot which one. But I remember thinking that there was this function for find element, right?
Mm-hmm.
That I just couldn't figure out how to make it constant time because you said all of them should be constant time except toString.
In Quest 9?
Yeah, I think so. Let me pull it up to make sure, but I'm pretty sure.
Yeah. Can you share that line with me?
I didn't
How
include
can
it.
you make find constant time in?
I don't know. That's why I asked. Yeah, it said, okay, it said important implementation note. With exception of toString and clear, all list methods below should operate in a constant amount of time regardless of the size of the string list instance.
Below, so what is the list of methods below? So I want to see.
Okay, the list of methods below is the constructor, destructor, insert at current, push back, push front, advance current, get current, remove at current, get size, rewind, clear, and then find item and toString. And I could do everything properly except find item. That one I can't figure out how to.
Yeah, no, I cannot imagine why find would be constant time.
Okay, so I wasn't being crazy.
Actually, clear should also not be constant time, right?
Yeah, but that was said in the top. It said except clear and toString should be
okay.
Constant time.
Find and this is a linked list.
Yes, it's a linked list.
Yeah, totally. Yeah, find so why I'm surprised nobody pointed out until now.
Maybe they didn't read
raise this question in the Reddit, Hiram.
Okay.
Also give me a chance when I respond to you. It'll also be a public, like kind of public announcement that other people also know that this.
Okay, that sounds good. Yeah.
Thank you so much.
I'll make the Reddit post. Yeah. Okay. Bye.
Cool. Bye. Fernando.
Mr. Anand, how are you?
How are you? How's your knee?
Everything. Well, sore right now.
Okay. Hey, so anyway, what are your plans? Are you planning to major in computer science? Or, this is many fields, and it's quite possible that you're majoring in something other than computer science. So I just need to know.
No, I am majoring in computer science.
You're sure about that?
Yeah, I'm just.
Okay, so if that is the case, so this is not enough, okay? I'm not saying that it's not your fault or anything. I'm saying that if you want to be successful in computer science, you got to take your time. What I mean by that is what you've done in 2A is not sufficient to go and do 2B at this time. So if people are pressuring you to say, well, get a pass in 2A, then go on and do 2B, you have to resist the urge to say no. Even if, whoever it is, if your parents or other people saying, no, you got to do this and start working soon, right? Then that means you got to start working harder, right? You got to say, no, I can't. I had an accident. I had my knee break or something like that, right?
Yeah. Because right now I'm worried about like passing your class.
You have to get to Quest 6, okay? If you don't get to Quest 6, you're not going to pass. And if you don't pass, it's actually good for you, I think, because you'll get to do it again. If you pass, you cannot do it again.
Yeah, right now I'm in Quest 5 and I'm working on it.
You'll finish it, right? Finish Quest 5, Quest 6. You finish Quest 6, I'll guarantee you pass. Okay?
Oh, okay.
So just finish Quest 6.
For the other quest, do we need to send you the code, or is
No. Nobody sends me any code from now on. Yeah. So you just complete the code and I can pick it up. Every single submission that you make, I can track it.
Okay.
Yeah. So that's why I'm saying, go ahead and submit it. Finish Quest 5, finish Quest 6. You have until week 12. That's 3 more weeks.
Yeah.
Can't you see yourself finishing Quest 6 in 3 weeks?
Yeah. I mean, I can finish Quest 8 if it's possible.
Yeah, Quest 8, you get better than pass.
Yeah, I want to get like at least a C+ or something like that.
Oh, you do Quest 8 and you'll get at least a B-, I think.
B-.
Yeah, because you've been attending class, you've been reasonably participative, you had an accident, you had life challenges, and you made it up to quest 8. That's fine, okay?
Guess what, Mr. Anand? Guess what happened to me too?
I'm sorry, guess what happens? I'm sorry, Fernando, I lost what you were saying.
Oh yeah. What happened to me was that, oh my God, I was driving last week and I blew my motor. Like,
you blew your motor in your car?
Yeah. I don't know what happened to it. I hit a pothole and destroyed my oil pan and my God, everything started to.
And then your car skidded out of control?
Yeah, and the motor like broke. Like, it turned
You know, fuck the motor.
Yeah.
But you are alive, right? I mean, did this happen on the highway?
Yeah, it happened on the highway.
Okay, all right. So these are situations which you can, and it's good that you were, you know, put out of action and been in bed for a few days. Okay, it's good that happened because those 2 days are the time we get to reflect and say, wow, you know, what a huge stroke of luck that I didn't lose an arm.
Yeah, true.
You could have lost your entire leg.
Yeah, true.
Yes.
Yeah, true.
Okay, all right. Now, what you have to imagine is that you have an alternate universe that you're running away from. In that other universe, you have a one-legged Fernando. Okay, and you've just managed to break free from that. You were running together, and that guy was catching up with you. Let's imagine you broke away just now.
Yeah.
So you are not in that stream of consciousness which had that broken leg. Right now, you just feel lucky, which means if you feel in those 2 days, if you just feel lucky for that, you'll start feeling a whole lot better. You'll do a lot better in everything that you have an opportunity to make a difference. Right? People who don't feel lucky, I find, don't put a lot of effort into anything. Right? When you feel lucky is when you start saying, everything I get is a gift. I just need to do the best I can. Because otherwise you don't justify your gift. So once you start feeling lucky for what you have, you'll say, you know, these 2 days made me realize how precious this opportunity to learn C++ is. These are things I could do. I could do this instead of being a Formula 100 driver. I could actually sit in my, you know, home in front of a swimming pool and code up a whole world. Yeah. So that power is being presented to you right now.
Yeah, true.
Okay, and all we need to do is just, you know, say, all right, I just want to put in a little bit more gas in my life, not in my car, so I can catch up with that.
Yeah, true.
Okay, all right, so gas up your life, not your car or your bike. Just catch up. Don't enroll in 2B unless you're ready, which means you have completed quest 9 of 2A on your own without other people's help. Yeah. Get to the place. Maybe it'll take you 1 month or 2 months. Read as much material as you want. Ask people for help, not in your code, but in concepts.
Yeah, true.
Me, friends, classmates, STEM tutors. But you have to do quest number 9 on your own, okay, without anybody's help. And if you get the password for green quest 1 by doing quest 9 on your own, you're 100% prepared to succeed in CS, computer science in general, okay?
Okay.
All right, so just take it, and if it doesn't work out, come back to me next year and tell me, you told me this, I tried it, didn't work, and I will not tell that to future students.
Okay.
Okay, I'll correct myself and not tell that to future students. So far, nobody has told me this. And I give the same advice every time.
Yeah, you're right.
Okay, all right, so you're going to have to believe me, not eternal, infinite belief, right? I'm not asking you to believe me like the Pope or something, right? I'm asking you to believe me, give me the benefit of doubt for 12 months.
Okay.
Okay?
Yeah.
After 12 months, examine what I said. If it hasn't been true, say, I'm not going to follow that and tell me to, right? I wasted 12 months. You don't have to waste it too, right? Put some serious effort. 12 weeks.
And I have a question too.
Yeah.
If let's say I do quest 8 and all that, I pass your class with the B and enroll in another computer science class, but a lower grade, is that good?
No, I don't think so.
No.
I don't think you should go into the next level of computer science classes. That is B level anywhere. CS1A, 2B, no, 1B, 2B, or 3B, any of the advanced computer science classes, right?
how about if I like not enroll in the higher standard one, but like one lower level than one
You're going to
A?
do the same thing again. What's the point in doing the same thing again?
Yeah.
Oh, you mean one level lower than this? So you can do 2A again.
Yeah.
Oh, I see. You're saying you need some fundamental, even more foundational knowledge than this that Foothill is currently not offering.
Yeah. You think
I see.
that's good?
You know, Fernando, you may be in luck. Yeah, thank you so much for telling me this information. Hopefully, I'll pass this on to Eric. Eric and Mike, I think there are two people in our department. Do you know them, Eric Reed and Mike Murphy?
No.
Okay, so they have been trying to champion exactly what you're saying, is saying that there are lots of students in our 1A, 2A, and 3A who are desperately in need of lower level computer fundamental knowledge. So we need to build an entire course for them. Okay, and Eric and Mike, I believe at this point, have created a new course called CS49, which addresses exactly what you want, which is basically to give you the foundational material to make you stronger and more successful in 1A, 2A, and 3A. Unfortunately, it's not available now, but I'm in the curriculum committee. So I passed the paperwork through and it's supposed to come through. Hopefully we should be offering it within a year. Okay, so you should be able to take that in 22, but you won't need to do it, okay? People after you may need to do that, but I don't think you need to do that. What you need to do is simply, instead of doing that course, you do something else you want, but that time spent in just reading module 0 and other material online, learning about computers from your first few pages of textbooks. These first few pages of all computer science books, they're just trying to, fill you up on the foundations, and it's very nicely done.
Yeah.
Don't waste time on a course. Someone who's coming in brand new, never done 2A, I would recommend it. You've done 2A, you've stuck with us so far. Just read it up, take a month off, a couple of months, come back to my 2B, okay? My 2B in, not winter, come back to my 2B in spring.
Spring, okay.
Okay, spring. And in winter, maybe don't do any computer science courses, but teach yourself computer science.
Yeah, you're right.
Okay, teach yourself, do leak code, learn up all the foundational material, read books, ask me for information if you want. Yeah, I'm happy to help, even though you're not going to be my student. I'll point you in the right directions and everything.
Okay, thank you so much for sharing.
Okay, do quest 6 first. Yeah, and that will take the tension off your head. Then after that, do quest 8 and also start working on quest 9.
Yeah.
Okay. And then we'll see where to go from there. Okay, don't worry about passing, right? Just make sure you're good and always remember you're lucky every moment, right? And say you got to do something to repay that luck.
Yeah, you're right.
Okay.
So when is the last day of class?
I don't know. I think next week is the last week I'm supposed to lecture, give you new material. Week 12, I'm happy to have classes, but technically there's no class on week 12.
So it's school
next Thursday.
December 6th?
No, next Thursday. What is next Thursday? Next Thursday is December 2nd, isn't it?
Thursday, yeah, December 2nd.
Yeah, so that is the last one.
That
is the last class. And then there is no class after that. Unless you guys want a class, okay? If you guys want a class, I'm happy to come and give you a class.
Okay,
if you don't want a class, I'm not going to give you a class. And then finals on Thursday, December 9.
Finals on Thursday, December 9. Okay.
Okay, and after that is winter break, which means that you should just work on quests whenever you have time. Green quests. Quest 9 here, and then start on the green as soon as you can. When you start on green earlier, you'll find that you're ahead of 50% of the students in my CS2B next year, right? Especially if you finish all the green quests over winter and enroll in my spring 2B, you're probably already done with all the quests, even on day 1. Yeah. So that'll be so cool, isn't it? You can basically hang around, help other people, come up with interesting things to do, variations, but you can have a great deal of fun.
Yeah. You're
right? So there you go. And then everybody will basically just ask you, right? Everybody will ask you for good ways to solve things. You can give, targeted good advice, right? Not giving away the solution, right? Just giving them interesting pointers and directions. That's gonna be a great deal of fun for you.
Yeah.
Right?
Yeah.
You can help other people. You can write tip sheets, right? Tip sheets, like, tips for quest 2, tips for, do these tip sheets, and it'll be really cool.
Mhm.
And you know what? Here's something for you, okay? If you come up with a good set of tip sheets for green quests, right? Quest 1 to quest 9 of green, just green, only 9 quests. Look at some past tip sheets that other people have done, and do something nice like that, and I can help you here and there. I am happy to guide you to put the 9 PDF documents for the quest together, along with your tip sheets in one small ebook. Okay, I'm going to show you how to make that ebook on Amazon. And you can sell it for 99 cents. And most of our students, right, won't care about spending 99 cents. Many students line up on KJ's Cafe. I see them spending like $7 on a coffee.
Yeah.
Right? Most of them don't care about spending 99 cents to get a collection of tip sheets on the quest that they're going to do for a particular course. Especially when you don't have to buy textbooks and other stuff on my course.
Yeah.
Right? So I'll just recommend it, saying if you're really stuck, just buy Fernando's tip sheets on Amazon. Right? So then you'll have not a huge source of income, but a moderate source of income. Maybe you'll pay for a couple of courses every quarter.
Yeah, sure.
Yeah, so you don't have to, ask other people to pay or things like that. You have some sense of security. And also the other side effect of this I'm hoping for is that by doing that and seeing other people benefit from what you have done, you will get a newfound enthusiasm for computer science.
Yeah.
Okay, then you'll see that, I'm able to help other people find joy in this. So obviously there is some joy in this already, because otherwise I can't help other people find joy in it.
Yeah, you're right.
Right? So what is it that, what is joyful? Let me get more of it. Right? So that's where you want to be.
Yeah, true.
Because that kind of joy never runs out.
Yeah, you're right.
See, all other kinds of joy, they're transient. Think about it, right? If I go to a party, if I have sex, if I have whatever it is, right? A good meal, whatever it is, right? Everything wins out after a while. Then you're back to square one. I'm sitting here, right?
Yeah.
So you got to find something that will basically sustain you continuously.
Yeah.
Right? And these are places where you can look for them. Or at least, we just, in an infinite graph, it's very important not to get lost in a path where you can search for infinite time, but not find the answer.
Yeah.
Right? So we want to guard against that. And that's what we use heuristics for. So, and so we just want to say, we'll just search in the high likelihood paths, not the low likelihood paths. And this is the way you find them, right? So, and don't go down paths that are proven time and again to just give you transient happiness. And then you'll actually find the path that gives you to, something that will sustain you forever and also spread the joy around you, right? More people will enjoy computer science. Look at Khan Academy, right? That guy started off something like this. He learned computer science and he said, there's so many cool things here. Lots of people should learn. So how can I make this cool for other people? And he made these YouTube videos, right?
Yeah.
So you can do things like this. Maybe you can do a talk show, and it's fun, right? And there's so many things, opportunities that will open up for you, because life is not. Many people who say that life is not worth living. I look at them and I talk to them. After a while, I find that they think that life is not worth living only because they cannot see a lot of opportunities. Because what is it that makes life worth living is that just a lot of opportunities. If people don't see opportunities around them, then life becomes not worth living.
Yeah, true.
It's hopeless, right?
Yeah.
Because if it's hopeless, you want to die.
Yeah, forever.
Yeah. And so I think that how do you find hope? How do you find opportunities around you? We got to set ourselves up to find opportunities. If you don't know C++, you're never going to find C++ opportunities.
Yeah.
Right? So I think just at this is the right age for you to basically commit to yourself to saying, okay, well, there's so many fields, there's a million fields on Earth, so many things I can be doing in life. Yes.
Yeah.
Well, if I think that if I at this age, if I haven't decided what to do, then I could spend a lot of time, maybe 20 years, sampling this, going to Whole Foods and go to the buffet bar, right? They have 15 different salads, 100 different salads. You want to decide what to do, you're going to sample every one of them, it's going to be pain. Say, no, this section, I'm going to find the best in this section. I'm going to enjoy it. Then chances are very high that you'll find the best ever.
Yeah.
So you say so many different fields. Now there's some, I don't know, chance that is thrust me into computer science, saying I have to major in computer science. Maybe my parents, maybe the Silicon Valley, maybe friends. Some I got stuck in there, and some money has been sunk already. I've spent 3 months learning computer science. Now I don't want to waste those 3 months. So instead, I'm just going to put more money into it, learn more computer science. Yeah.
Yeah.
And then make a big thing out of it. And I have so many more opportunities now. Right now, I won't feel like a total waste because I have opportunities.
Yeah, you're right.
All right. So set yourself up opportunities. Don't waste time, because all of these things, games, everything, they'll all go after a while. Right. 2 years from now, the top games today, not going to be top anymore. Right. Even Fortnite, unless there is a hugely paradigm shifting variation that's played entirely in the metaverse, right? In a make-believe universe of Amazon or Facebook or something like that, where your real characters really, right? Look around you and all. No, people are not going to be spending time sitting in front of a TV.
Yeah.
Everything is going to change.
That's what my dad tells me to not.
Yeah, everything is going to change. So don't waste time with dated technology. Just observe it to see where things are going, but you don't have to invest time in learning these things in detail, right? Because even if you get into a game, like, this is one time, many years ago, I was talking about this with my son. So he was very interested in Halo. And he was also pretty good at, going on the online forums and getting the badge, the top badge or something like that. And he told me once there's a convention in Vegas that happens every year where the top Halo players get together and they duke against each other. And the prizes are like horrendously big, like, millions of dollars. If you nuke everyone in that Halo match, you get lots and lots of money, and streaming rights and on Twitch and everything. And I asked him, "Are you planning to do that kind of stuff?" And he said, "There's no way. If I want to do that, I have to put in a 100x more effort than it'll take me to master C++."
Yeah.
Yes.
Yeah, you're right.
Yeah. Okay. So, and in fact, I actually liked it very much. And imagine if you hear that from someone who you think that maybe going down the wrong road, you are actually very much reassured, saying, "Okay, well, that person has a sight set right."
Yeah.
Right. So that's what you want to know. And yeah, I wish you the best of luck, Fernando. And I don't want you to give up. And I want you to take this accident that happened to you as an eye-opening opportunity, right? Where you actually get to see how lucky you were and make the best use of this luck, and in repaying the world for something good that happened to you.
Yeah, you're right, Mr. Renan. Thank you so much for the words. I really appreciate
All right.
it.
Yeah, no worries. I'm happy you're coming back. Okay. Many classes you're absent, and I talk to you and you're not speaking back. And I know that everybody has a life, and things could be happening in people's lives that I have no window into.
Yeah.
Right. So all I can think of when things like that happen is that something bad is not happening to you.
Yeah. Thank you.
Okay. So I'm glad you came back, and you're in one piece. So hopefully one day in the future, I can read about something great that you did.
Yeah. Thank you, Mr. Nan.
All right. Okay. So best of luck, and then keep plugging ahead, and make sure you complete quest 6, and that's a pass. And then quest 8, I will give you a B.
Okay.
Okay.
And I would like, what's the size of your shirt? What's the size of your shirt?
I don't know. I'm basically at this point, I'm just giving away all my shirts so that I don't have that many. Because if I have too many shirts, it's too many problems.
I would like to get you something.
No, don't. Please don't get me anything. Right? That's an explicit request I have to every single one of even my son. Okay. Yeah. Really, I'm not son anymore. He's more like a close friend. Everybody's like close. So never get me anything. Okay. Because I'm at a stage where I'm trying to get rid of things.
Yeah.
Yeah. So even money, really. If there's deserving candidates who can do with money, I'm happy to give them money if it will help them achieve their goals. But I don't want anything at this point in time. Okay, I found what I want in life. So don't get me anything. Please don't get me anything. Okay, if you're going to an interview and you need a 3-piece suit, okay, tailored 3-piece suit, just send me an email. I'll give you my suit. Because it's been hanging in my closet, in that bag for years, and I've not worn it.
Yeah.
Okay, so I'm happy to give away everything that belongs to me. Please don't give me anything. All right, so best of luck to you.
Okay, thank you, Mr. Nan.
All right, see you later.
See you.